All right, so beginning to do some problems in Chapter 3, which is on stoichiometry of formulas and equations. So just to remind ourselves what Chapters 1 and 2 were about, Chapter 1 was really kind of an introduction to chemistry, and we learned about matter, we learned about physical and chemical changes, and importantly, we learned about unit conversions. So the idea is that unit conversion, or something called dimensional analysis, is going to be a valuable tool in general chemistry, and we'll see that applied in this chapter. So that was kind of some of the main things from Chapter 1. And then in Chapter 2, we learned about the atom and elements, compounds, and mixtures. And importantly, we learned how to create formulas, whether they're ionic or covalent, and naming substances. So again, this becomes an important component of Chapter 3, as many of the problems give you the substance as just a chemical name. And so in order to even be able to do the problem, you have to take that chemical name and make it into a correct formula in order to balance an equation and so forth. All right, so as I like to do usually with the first problem, which will always end up being a little bit longer, I like to give an overview for the chapter to kind of highlight the things that are important in this chapter. So in Chapter 3, we introduce the concept of the mole, which is how chemists like to count things, and it is the walk between for many different things. So we do this game, and I'll come back to this at the end, but we have this, I call it a mole game board that we walk between. And the idea is once you get to moles of substances, that allows you to walk between different ways of thinking about substances, whether it's the mass of the substance, the volume of the substance, the total number of entities, and we'll learn different unit conversions that will allow us to walk between different ways of representing amounts of substances, be they moles, be they volumes, be they quantities that we're counting, and so forth. So the mole is an important concept for us to be able to think about and also to use unit conversions. So we'll have a few sample problems that we'll practice with that. Then we think about empirical molecular formulas and the different ways that we can represent formulas. We introduce the concept of structural formulas in this chapter, but we really won't get into much detail on that until much later chapters. Then we move on to balancing chemical equations. As we'll see in this chapter, having a balanced chemical equation is essential to be able to do a lot of the calculations that we'll see throughout this course. Related to that, again, is stoichiometry, so thinking about reagent quantities, the concept of limiting reactants, calculating yields. And so as it says here, solving stoichiometry problems uses a balanced chemical equation to determine the amounts of materials in a reaction. So pulling on stuff again earlier in Chapter 3, being able to think about empirical molecular formulas, and then again from Chapter 2, being able to think about correct formulas from names. So again, a lot of problems deal with stoichiometry, so we'll have several sample problems that we'll practice then, and then there's lots of problems with homework. So stoichiometry is kind of a very important aspect to this chapter. And then not unrelated is the concept of solution chemistry. So it's the idea of doing chemistry but in solutions, and so we have some qualitative aspects of why it's important to think about solution chemistry, but then again doing solution stoichiometry problems is not unlike what we'll work on in this fourth section here, but again this fifth skill has the concept of, you know what, we're not going to walk between masses of substance to get to moles, we're going to go between volumes of substances to get to moles, and we need to use molarity or a concentration when we're dealing with these solution chemistry problems. Okay, so working through, we have several problems. There's 14 problems that I'm actually going to post videos for in Chapter 3. So here is the first one. So again, these first three problems have to do with the concept of the mole and how we interconvert information that's given to us. For example, this first problem is they're giving us a mass of an element, and we need to then calculate the number of entities. So we have to walk between the information that's given to us, so the mass of the substance, and then the number of atoms. So I like to often write down solutions to problems by starting by saying, you know what, what's information that we know, and then where do we want to go? And so for this problem, we know that we have 95.8 grams of iron. What I'm really going to be doing is recreating what's called a roadmap that your book goes through conceptually. So I'll do this, I call it a know to go, and we'll write down information that we know, and we'll think about where we want to go, and that's answering the question. So how many iron atoms? That's the question. So that's where we want to go. So we'll say how many. So that's a quantity. So how many iron atoms? And then what we need to do is think about how we're going to walk there. Well, a good first approximation anytime you're starting a problem is if you're given something in a mass, go to moles. So if we want to get to moles of iron, we can do that using the molecular weight. And the molecular weight of iron is 55.85 grams per mole. And again, because this is an element, we get this directly, iron solid, off of the periodic table. Now that we know moles of iron, we can walk from moles of iron directly to quantity using Avogadro's number. And that is that there's 6.022 times 10 to the 23rd, not molecules here, we're talking about atoms. So it's a quantity, so it could be molecules, it could be atoms, it could be ions. In this case, it's atoms of iron in 1 mole of iron. So one thing to just kind of make sure that you see here, we have units of moles and we want to walk to atoms, quantity of atoms. So our unit conversions are things that will have both of those units. So if we want to walk between moles and atoms, we need a unit conversion that relates moles and atoms. Similarly, when we wanted to walk from grams to mole, molecular weight is a unit conversion that has grams and moles in its units. So that's kind of a good piece of information to remember. If you want to walk between two substances, do we know a piece of information that relates, I shouldn't say two substances, two units? Do we have a piece of information that walks us between those different units? And that's what this is going to be really helpful for in this chapter. We want to walk between mass to amount. We use the molecular weight. That's what this little scripty M refers to. I write MW to stand for molecular weight. So walking between grams and moles, we need to have a unit conversion that has the same units, grams and moles. And then walking between moles and atoms here, or quantity, we use Avogadro's number. And again, Avogadro's number is 6.022 times 10 to the 23rd. It is the number of items, and since we're talking about atoms of iron, it's in 1 mole. So this is our roadmap that is essentially the same thing that we've provided for your book. So oftentimes the hardest thing is making your roadmap, figuring out what information am I given and how do I get to where I want to go. Now I'll tell you, so many of these problems are so related. What makes them easier or more difficult is how directly information is given to you. So for example, the first 2 sample problems are just walks between grams and moles, and then moles and quantities. So I've started with sample problem 3.3, which actually has you take 2 steps in 1 problem. So again, the easier the problem is, the fewer steps it'll have, and the easier it is to walk between the information you're given and where you want to go. Okay, so once you have this roadmap in place, you just execute it. So this is where our unit conversion comes in. So 95.8 grams of iron. How we want to use these unit conversions, because the 55 grams per mole, just as a little side note, can be used as 55.85 grams of iron over 1 mole of iron, or it could be used as 1 mole of iron is equal to 55.85 grams of iron. It can be used in either way. What determines how we're going to use it is what we want to have go away here. So you see here we have units of grams of iron. We want grams of iron to go away, which means grams of iron have to go down here. When we have grams of iron down here, that means we are using this this representation of this unit conversion of molecular weight. So the 55.85 has to go in the denominator. 1 mole of iron goes on top. These units will cancel, and we'll see we're at the units that we wanted to get to, moles of iron. Now, we want moles of iron to go away. So again, 1 mole of iron. And this again, we're going to use this unit conversion as we've written here. It could be used in the opposite way if we wanted to, for example, walk from atoms to moles. But in this case, we want to walk from moles to atoms. So we use it as written here. times 6.022 times 10 to the 23rd atoms of iron. And early on here, especially until you get very good at this, make sure that every time you write a value, it has a unit with it. And not only are quantities going to have a value and a unit, it should have an identity of a substance that goes with that value and that unit. Because it's not uncommon for people to miss, especially as we get into problems where we're changing who we're talking to or talking about, to have an incorrect mole to mole conversion because they just have moles and they don't have moles of who it is. Okay, so go through, mathematically solve this problem. And solving it, again, if we look at how many significant figures we should have 3 significant figures. So we get 1.03295 times 10 to the 24th. In our calculator, we want 3 significant figures, so that's going to be 1.03 times 10 to the 24th atoms of iron. And again, we can see moles of iron will cancel. The units that we're left with at the end are atoms of iron. So I know I went through this first problem. It took quite a long time to get through one problem. The rest of them, I promise, won't be that long. But part of it was we introduced the chapter and the 5 skills that we're going to learn and tied in previous chapters information that's going to be essential to solving problems in this chapter.